Hey there, it's the Reckless Retiree. Who is that, you might ask? Well, let me explain a bit. I have had 38 years of experience as an engineering technician in the aerospace and automotive realms, doing research and development testing on new ideas and concepts that are set to make and save money for these industries. And so I've done some very interesting projects. And the thing about R&D is it's just kind of a trial and error thing. I mean, it's scientific. You scientifically come up with a concept, and then you sketch it out on paper, and then you experiment with it in the lab and see if it's going to work or not work. And for the companies that do this, often it's a tax write-off because a lot of money is spent on ideas that don't succeed. But with the few that do, then you can proceed with producing such products and making a lot of money, and that's what they do. That's what I did, the testing. So let me give you an example of some projects that succeeded and didn't succeed. First one's an example of an idea that didn't succeed, and that was we were making the B-1 bomber wings, and we were making what they call wing skins that go on the outside of the wing. But that, if you've ever looked at a wing in the airplane, when you're sitting in the airplane, you obviously see that they're curved. And they have to be curved to give lift to the wing. The air travels, I think it's the air travels faster over the wing than under the wing, or vice versa, and therefore that difference in speed causes a vacuum, and therefore produces lift and lifts the wing and the plane off the ground. So we had to come up with, we had to make these wing skins out of aluminum. Solid piece of aluminum had to be machined down into a wing skin. And it had to have attachment points and such. And they did this on a giant skin mill, they call it. And the idea that they came up with was a way to verify that the thicknesses were exactly what they had been designed to be as it was being machined. And it's kind of a quality control effort. And so the engineer came up with the idea of using ultrasonic sensors to touch on the wing skin and read the thickness, and do this periodically during the machining of the wing skin so that we would know that it was exactly the thickness it needed to be, and no more or no less. So I got sent to California for a 2-week training on ultrasonic inspection, learning how to use these sensors. And then I came back, and with the design of the electrical engineer, I built a control panel that would, in a mechanical pneumatic cylinder, that would extend and retract on command. And this could happen automatically, periodically, at a certain time sequence while it's being machined, or it could be done manually by the operator. So this was 6 months to a year easily in the making, and we tested it in the lab. It worked. We took it out to the wing skin mill and put it on the head of the mill, and showed the operator how it worked, and told him we wanted to use it and give us some feedback. So we came back a certain period of time later. I can't remember exactly how long it was, And what we had very carefully placed on the head of the mill was now thrown in a pile in the corner. And his only comment was, it was in my way. And so that was the end of it. 6 months to a year of work, and it was done. Pretty crazy, huh? But an example of something that did work was these same wing skins had to be a certain curvature, and you had to machine out the wing skin and then form it to a certain curvature to match the ribs, they called them, in the inner wing to give the curvature to the wing. And they were having difficulty doing this. The way they would do it is they would have these curved boards, which were actually aluminum, periodically down the length of the wing skin, and then they would they would have it on top of those curved boards, and they would drop metal shot on top of this. They called it metal shot forming of metal. And the idea was they keep doing this until it conformed to those boards. But that wasn't working. And the B1 program was in jeopardy, and they were running out of time. And so they came up with another idea in our lab, and that was to do it with pressure, vacuum, and heat. And so we made this giant box, the size of a wing, a large airplane wing, and it had the contour boards in it, and the wing skin would become the lid of this box, sitting on these contour boards, on the tops of the contour boards. And then we took high temperature silicon rubber and we sealed the edge, and then held that down with metal shot bags, and we pulled a vacuum on it, and it forced the wing skin to come down part way to the contour boards. Then we took this box and we placed it in an autoclave. Now, you may have heard of autoclaves being used to sterilize surgical tools to make sure that they don't cause infection when they're used. And so imagine this much, much larger. Here you can see a picture of myself with the other folks, the engineers and technicians that worked on this program, and the autoclave with the box I'm talking about in it. Okay, so you put the box into this autoclave, you sealed it in there, you put pressure on the outside of it, which forced the wing skin even more onto the contour boards, but not quite there yet. And then you heated it up to a certain temperature, and I don't remember what that was, but it was a fairly high temperature where aluminum would become more malleable, I guess you'd say, conformable. And so those three processes, the vacuum, the pressure, and the heat, caused the wing skin to come down completely on the contour boards, and you bake it for a certain period of time, then pull it out. It would spring back a certain value that they calculated. So in other words, the contour boards were more curvature than you needed, but when it sprung back, it was exactly what you wanted. And so my job was the instrumentation that was used to monitor the curving of this wing skin in the autoclave. And so I had to install thermocouples, which measured the temperature in various places in the box and in the autoclave. Had to install I had to do research in that I had to call multiple companies looking for high temperature LVDTs. Now, what's an LVDT? Never heard of that probably, right? Linear variable transformer displacement, LVDT. Linear variable displacement transformer. Pretty fancy name, isn't it? Basically, it was a coil of wire with a rod that was spring-loaded, so it was held out of the coil, and as it was pushed into the coil, it would change the reading, which could be then calibrated to tell you exactly how far it had moved. So I had to order these transducers. I had to figure out how to mount them, or maybe the engineers figured that out and I just did it. I don't remember. And then we had to mount them on the boards, the curvature boards, so that as the wing skin moved, first of all with vacuum, second of all with pressure, third of all with temperature, we can monitor that all while it took place. These had to be very high temperature LVDTs, which took a lot to find. And so it took, maybe a week of calling different places to asking, and maybe not a week, a few days. Anyway, so we had to order them and mount them and wire them up in the autoclave and monitor them during the test, which I thought was a lot of fun. Really enjoyed it. And we were very successful, and the B1 program went on. And here you'll see the quote-unquote award I got from my boss's boss for being successful in that. So, why should you listen to me? What am I doing that's worthwhile? Well, I'm carrying over this whole experience as a R&D technician into my own life, into our lives, come up with ways to save money and to make money with things we can do on a shoestring at home. And so what I'm trying to do is make, store, and use hydrogen. And hydrogen is a fuel, and it's the only fuel you can make yourself, as far as I know. I mean, I suppose you could process cooking oil, but I'm making it right now with aluminum, scrap aluminum, and lye. The lye I'm making from hardwood ashes, and the scrap aluminum I'm hoping to get from people who would throw their cans away instead of returning them for the deposit, because there are millions of people who do this. You can see evidence of this online. So I'm hoping to get those cans, other things, cooking utensils and stuff, disposable and such, that people will give, and then process that into hydrogen to cook, to heat, to run a generator, to use in a hydrogen cell, forgot the name of it, and also, anyway, there's many ways you can use hydrogen. You can make it easily yourself. So I'm doing R&D on how to do that. Secondly, I'm coming up with a way to recycle platinum group metals that are on the road surfaces that come from catalytic converters and that need to be used in catalytic converters, new ones, and also electronics. So it'd be better for us to recycle this than to remake it and to pay these other countries to do it for us. So I'm hoping that to show you how to do these things. And I'm doing it in such a way that you see the long story, the pain and tribulation, but the joys of the process, kind of like if you've seen Curse of Oak Island. It's a long drawn out process to try to reach a goal, but it's fun to watch them go through that process. Hopefully you'll enjoy my process going through it and be able to reproduce it yourself. So stay tuned to the Reckless Retiree.